lesson 4. We're going to be working with some rational exponents. Rational meaning fractions, and then we know what exponents are. So you're going to be dealing with exponents that look like fractions, and you can see what that looks like right here. So those are actually the exact same as radicals. So we have our rational exponent form, and then we have our radical form. So this first little upper box right here is going to teach you how to translate back and forth into exponential form versus radical form. So if you ever see this 1 over n, when you have n as a denominator in your exponent, that n is actually the index of a radical. And then a becomes the radicand. 1 is like your exponent in here, but a to the first, we don't really need to write that. So this is just the nth root of a. And then this exact same thing, when you have a denominator of your exponent, that turns into the index. A is your radicand, and then m actually stays on as an exponent for the a. So really, like, a is still raised to the m. This n just gets tucked in as an index. And then same thing here. A is just raised to the first. The n gets tucked in as an index. So this first section, we're just going to be translating back and forth just to make sure you understand exactly how these work. So we're going to do a handful of these. So if you look at number 3, for instance, this 3 as the denominator gets tucked into the index. 24 is the radicand, and then 1 is your exponent, which you don't need to write. So the cubed root of 24, that's something that we can simplify down. 24 is not a perfect cube, but it is a multiple of 8. So we can split it into 8 and 3. Okay, so the cube root of 8 is 2, and then for your leftovers, make sure you write the index every time, because the cube root of 3 is not the same as the square root of 3. So you've got to make sure you're actually writing that. So this is what that completely simplifies down to. Next, let's do 4 and 5. So just to write down the exponent here, I'm sorry, this denominator becomes the index. So 3 turns into the index, and then you have 7 squared on the inside. So 7 is the radicand, the 2 here becomes your exponent, and then we can rewrite that. So 7 squared is 49. And that actually doesn't simplify down at all, because the only divisors of 49 are 7, but there's only 2 copies. So it's not any perfect cubes in there. But it's the cube root of 49 is the same as 7 raised to the 2/3 power. Let's do 5 as well. So the 2 from the denominator here becomes the index. And if the index is 2, you don't actually have to write it, because that just means that it's a square root. And then k raised to the 7th power goes in the inside here. So whenever you see that, the exponent there, the 7, is way too big to stay on the inside. We're going to have to simplify some of that up. So remember, these are maximum, our maximum power that can go in there is 2. So in order to be a perfect square, it has to be an even exponent. So we're going to split it up. 7 obviously is not even, but we can do k to the 6th, and then that would leave 1 remaining copy of k. So the square root of k to the 6th, remember our little dividing rule, 6 divided by the index of 2 means k to the 3rd can come out, because you have k to the 3rd times k to the 3rd, that's k to the 6th, and then you have just this 1 remaining leftover copy. So that's where all of our 7 exponents ended up. Let's do the one right underneath it here. This cube, the 3, becomes our index. And then we have negative 6x in parentheses still raised to that 2nd power. So the 2 goes here, the 3 goes here. Now let's simplify that up. So when I square a negative 6, I get 36, and then x to the 2nd power. So 36, we're looking for perfect cube factors. It's not divisible by 8, it's not divisible by 27, and that's it. Those are the only ones that are smaller than 36. So that is actually as simplified as it will get. An x squared, 2 is smaller than 3, so we know we can't pull any factors out there. Now let's look at one more in this section. 1/2 means that 2 becomes your index. This 7 is not part of the exponent, so the 7 is actually still on the outside, and then our index is a 2. The 12w goes on the inside. It's technically raised to the 1st power. So then the 12, we can split that into 4 and 3. So the square root of 4 can simplify out. There's still a 3, and the w is still under there, because there's only 1 copy, so it's not enough to bring out of the square root. So square root of 4 is 2. Multiply that by the 7 that was already there, and that is our simplified radical form for number 9. All right, bottom section, we're going back in the other direction. So if you can start out in this form, that means you should be able to write it in this form. So whatever you have here becomes the numerator for your exponent. Whatever you have here becomes the denominator for your exponent. So we're gonna do a handful of these, starting with number 10. So 16 is your radicand. 16 doesn't have an exponent, so we just assume that it's 1, and then the 3 from the index becomes your denominator. So make sure that you're not writing it like it's a mixed fraction. Make sure it's clearly an exponent, like 1/3 is written as an exponent. So just writing it in exponential form, there's really no simplifying that you do. You just write an exponent. All right, let's go underneath 13. 11 is your radicand. The 2 becomes your numerator for the exponent, and then this 3 right here becomes the denominator. So that's it. No simplifying, just writing it in its exponential form. Let's do 14 as well. So k is your radicand. 5 is the numerator for the exponent, and then this 4 is the denominator. And that's it. So this direction is much faster, much simpler. And one more. When you have all this stuff going on under here, you just put it in a big set of parentheses. And then there is no additional exponent out there, so we just say 1 over our index, which is 3. So if it's under a big cube root, that just means that you're raising it to the 1/3 power. So that direction, as you can obviously see, goes much more quickly. So let's look on the next page. Now we're actually going to be using some of our exponent rules to simplify some of these things up. So we have a step-by-step process up here, simplifying expressions with rational exponents. So we're going to start with number 19. Follow a step-by-step process here. Number 19, we have base to an exponent times a base to an exponent. So first of all, you want to make sure everything's in exponential form, which these already are. Use the exponent rule. So the exponent rule here says if you have two separate powers like this and you're multiplying in the middle, you add those exponents together. So we add 1/3 and 4/3, and we get 5/3 as our exponent. And then we can write it as a radical in simplest form. So now to write it as a radical, the 3 tucks under here and becomes the index. And then we have x to the 5th. Now I can't leave a 5 under an index of 3 because it's too big. So I'm going to split out what I can reduce and what I can't. So remember, I need multiples of 3. So out of those 5 powers, I can put 3 to reduce, and then that will leave 2 that can't reduce. So I have all 5 copies here. The cube root of x cubed means that I have an x that I can bring out. And then I have the cube root of x squared as my leftovers. As long as this is smaller, I know that that is as simplified as it will get. So that's number 19. We're going to do the odds for a little bit, and then we'll switch over to evens. So this one right here, when I have 1 in the numerator, 1 in the denominator, my rule says that I subtract those exponents. So my new exponent would be 5/2 minus 7/4. Now obviously these don't have the same denominator, so I'm going to change them so that they do. So 4 is what I can use. So instead of 5/2, I can write that as 10/4, and then I can subtract 7/4. So that gives me 3/4 as my exponent, and then I just rewrite that. So the 4 from the denominator tucks in and becomes my index, and then I have m to the 3rd. So as long as 3 is smaller than 4, that is as simplified as it will get. Okay, we're going to do 23 and 25, then switch over to the evens. So this one right here, if I have an exponent raised to another exponent, my exponent rule tells me that I multiply them. So I multiply 1/2 times 1/2, and I get 1/4. So my new exponent there is a 1/4. Now I'm going to put it into its radical form. So the 4 becomes my index, 4th root of 32. 32 is not a perfect 4th root, but it's a multiple of 16. So I can separate out 4th root of 16, 4th root of 2. So the 4th root of 16 is 2, and then for my leftovers, make sure you have the index written there, because the 4th root of 2 is different from the square root of 2. All right, this one as well. Another exponent rule tells me that if I have a negative exponent, I flip and I write it in the denominator, like it's a fraction. So I write 1/, and then I write 100 to the 1/2 power. All right, so negative exponents get flipped to the bottom of the fraction there. And then I can rewrite it. So 1/2 as an exponent is the same as the square root. So my index becomes 2, but we know that's just a square root. So it's just 1 over the square root of 100. And the square root of 100 is 10. So that just becomes a nice, neat 1/10. All right, for a little bit, we're gonna switch over to the evens here. So we're gonna do the evens, and we're actually gonna do both of these bottom ones. So evens over here, negative 1/4 power. If the entire thing is raised to the negative 1/4 power, you know, this negative made me flip down the 100. This is a fraction, so the negative is actually gonna make me flip the entire fraction to 7 over 112, and then I raise that to the positive 1/4 power. Okay, so this, it flips the fraction and it changes this to a positive exponent. 7 over 112 actually reduces. 112, you might have to plug it into your calculator to find out, but it is a multiple of 7. It's 16 times 7. So if I reduce this down by 7, I end up with 1 over 16, and that is raised to the 1/4 power. So 1/4 means that it is an index of 4, and those are both perfect fourth powers. So the 4th root of 1 is just 1, the 4th root of 16 is just 2. So like this crazy looking thing right here is actually just 1/2 once we simplify it. All right, number 30. So when we're now getting to the point where we have to do step 1, rewriting all radicals in exponential form. So this, when I have 4 as an index, 3 on the inside here, that's r to the 3 over 4 power times, and this is the square root. Remember, that means the index is 2. So the index of 2 means this is the 1/2 power. So add those exponents just like I did with number 19 here. So to add these together, they need to have the same denominator. So 3/4 plus 1/2, which is actually 2/4. So I add these together, 3/4 and 2/4 would be 5/4, which I can then turn back into a radical, and I'll have to simplify it. So this, the 4 becomes my index, the 5 is my exponent on the inside here, and then since 5 is bigger than 4, I have to break it up. So for 4, I'm going to take 4 of the copies and put them here, and then put the last copy right here. I'm going to sneak this in. 4th root of r to the 4th is an r, and then I still have a 4th root of r. Make sure you write that index every time. All right, we're going to do the last 3 here, 32, 33, and 34. So 32, we can write this as 7 to the 3 over 2 power. Remember, the index of 2 becomes the denominator when I turn it into my exponential form. Over, and then this is just 7 raised to the 1/2 power, because just the square root would be the 1/2 power. Now my bases are 7. I look at my exponents. So this is actually just like this. Don't let the 7 part freak you out. 7 is just the base, just means that I subtract the exponents like I did with 21. So subtract the exponents. 3/2 minus 1/2 would be 2/2, and 2/2 is just 1, so that means it's just 7. All right, and these bottom ones, we're going to use some exponents here. So the 4th root of x to the 10th. So first of all, we want to put that in exponential form. So the 10 is my numerator, the 4 is my denominator. That will reduce, right? Like 10 over 4, I can reduce that down to 5 over 2. So now I've got it simplified. Now I'm going to take it back into my radical form. So this 2 becomes the square root of x to the 5th. And now I'm in kind of a similar situation to what I had with like this one, except my index is 2 instead of 3. So square root of x to the 5th, I can take 4 of them here because 4 is even, and then that would leave me with 1 left over right here. So the square root of x to the 4th would be x squared. Remember, because x squared times x squared would be x to the 4th. And I have this little leftover right here. One final one here, 25m to the 2nd power. So I take 25 itself, that is raised to the 1/4 power because it's under the 4th root like that. And then m to the 2nd, we also take that 4. So they both separately are under the 4th root, so I have to write them both like that. All right, so this 25, I'm going to write that as 5 to the 2nd, and then that is raised to the 1/4 power. My m, 2 over 4 reduces down to 1 over 2, so I can do that. Now this exponent raised to an exponent, just like this one right here, says that I'm supposed to multiply them. So multiply 2 times 1/4, which is 2/4, and that's 1/2. and then I have m to the 1/2. So both of these are raised to the 1/2 exponent, which means both of them should be under a square root, the 5 and the m. So the fourth root of 25m squared is actually the same thing as the square root of just a 5m. All right, so lots of exponents, lots of different things kind of combining into one topic there.